Everybody, this is an intro to our next big project, which is working with data and data visualization. So I think let's start with Venn diagrams. This is a good time to get out your worksheet that I've attached to Blackboard. Venn diagrams are kind of fun, and I'm sure this is not the first time you've seen all these funny Venn diagrams floating around. But and you guys are allowed to change the title of the Venn diagram I attached. This is just for fun. This is just to like get nimble with data visualizations and start with something super easy. So what I want you to do is take the worksheet that I gave you, the Venn diagram sheet. You can change the title and make this anything you want. It can be funny, it can be serious, whatever. And then take a picture of it or save it and upload it to our Slack group. I've created a separate channel just for these, and you can get some extra points by doing that. So please do it. It's worth 10 points. And make sure that if your name is not attached to your Slack account, that I know whose it is so I can give you those points. So basics of Venn diagrams, they basically show commonalities and differences. And they're really just like fast, quick, simple visualizations of information. So this is not a data visualization that you would think of as in like representing really complex numerical data, but it's still taking information and representing it graphically. So that's why I wanted to start here. But that's the reason, like the fact that they're so simple also makes them easily misleading. I could take any three things, throw it into a Venn diagram, and make a graphical representation of it. It doesn't necessarily mean that that commonality is true or that I have any information or research or data to back it up. It just means I've thrown it into a Venn diagram. As you guys know, as you read these and each other's and make them, you can put pretty much anything in there and make some kind of point, argument, or joke. So these are for bigger like conceptual issues people use Venn diagrams for, not for more nuanced specific data. Okay, so what is data? This is seems pretty simple, but might not be what you're thinking. Data is not necessarily just quantitative numerical information. Data can be observational data, so if you're in the social sciences or in doing medical research or something, it can be observational data, so you watch people to see what they do and then record what they're doing. Data can come from a lab or an experiment of some kind. Data can come from large-scale or small-scale computer simulations where we run something through a program and then figure out what the output is, and then we have some new information we didn't have before. We do a lot of textual analysis, so looking rhetorically at what people say and how they say it, and if you do that with enough rigor and with a focus on analysis, then that can be data to make a point, find new information, make an argument. Physical artifacts can also be data depending on what you're looking at, what questions you're asking about them, and how you're handling them. Something like the amount of bacteria in a cell counted over and over again, that becomes data now to have to make some argument about what those bacterium are doing. Okay? So data is really just information in its raw form, and it represents conditions, ideas, processes, or objects. And data is everywhere. We can turn just about anything we can see, feel, think about, touch into a piece of data, and it really just depends on how we're using it. So, why we're focusing on this so much in a business writing class is that data visualizations is something that we can use to make sense of the world. Visualizations can be quick, memorable ways to get an audience intimately acquainted with your data or an argument that you're making. And data visualizations can also be great ways to make sense of the data that's in front of you. So if we have a big table of dispersed quantitative numerical data, by organizing it and then visualizing it, we can start to see trends or groups or categorizations that's hard to sort of conceptualize in our brain until we see a picture of it. It makes things more clear. So it helps us organize, really make sense out of data. Data can help us see bigger pictures than what we think about like instantaneously when we're looking at data. So graphics help us break down large and complex data sets into something that's a little more intellectually manageable. And as we represent data differently in different kinds of visual ways, we can sometimes get a different narrative if we're looking at this bigger picture rather than focusing in on smaller data sets or smaller segments of this information that we're collecting. We also want to learn how to look outside of the data. So think about context. Rhetoric is nothing if not thinking about context, context, context. When looking at data or data visualizations, you have to consider how the data was collected, where it came from, when it was collected, and what was going on at the time that might have had an impact on data and the collection of data. So we're really not just looking at a visualization. We have to think about who collected it, how it was collected, why it was collected, because there are lots of reasons for people to collect data and parse it the way that they do. It's not always just common sense, here's what happened, but it's decisions that we have to make. And every decision we make as a person, as a researcher, as a person dealing with data is really a rhetorical decision. We have reasons behind that, but it's always impacted by the context around us as the people who collect and represent data, and also the data itself. This is a big part of data literacy, is learning to figure out who collected stuff and why and how, so that we can make really ethical and more sound judgments about if the data is saying what we think it's saying. And data literacy is becoming more and more important because we're so connected, because we see stuff all the time online, and we don't really always know if it's true or not. Again, we can represent anything graphically. It doesn't necessarily mean that that was ethically collected or that it's represented in an ethical or sound way. So looking at data this way helps you guys be able to look at data and data visualizations anywhere and really determine in a sound way if that data makes sense, if it's being used ethically and represented ethically. So it makes you guys better readers and researchers and sort of better knowers in the world when you encounter data visualizations. And then the final one, when you see like a blip in a graph or an outlier, you should always wonder why it's there, what it is and why it's there. And if you find some kind of correlation in information or bits of data, you should always think about whether or not that correlation really makes sense, whether or not it's true. Sometimes it seems to make sense, but it doesn't always make it a useful correlation. If it does make sense, then cool, but if not, you have to start digging deeper and really looking into that information. Numbers are amazing, but there's always a difference between correlation and causation when you see two graphs or two sets of data that sort of are correlated. Doesn't necessarily mean that one caused the other or that they have any actual relationship, and we'll talk about that in a bit. So I've included a link here. This is a website specifically dedicated to correlation and causation, where this guy just takes big data sets and then he graphically represents them, usually on line graphs, and shows two things that are correlated. So they have the same line. The line goes up at the same time for both things and it comes down at the same time for both things, but it doesn't necessarily mean one is causing the other. It just means those trends seem to happen along the same line. If you go to the link, then you'll see what I mean. It's like ridiculous things. The other reason why we're studying this is because we live in an increasingly visual environment. So you guys, more than me when I was your age, have to deal with visual stuff way, way more. Especially because our face is in our computer screens all the time. We're just working in the visual more than we're working in text and numbers, or at least more than we did 20, 30, 50, 100 years ago. And because we're doing that, you guys have to be really data literate and really visually literate to be able to parse things out, but also create things that are visually stimulating, that are visually ethical, and that make sense in this visual environment. Data visualizations are also really useful because it's one of the fastest ways we know until we can just insert something into our brain and download information. Data visualization is really the fastest way we can make an argument or get somebody to understand what we're saying. So knowing how they operate and figuring out how to use them can be a really, really great tool for you guys to use. Data visualizations are also highly rhetorical. And what I mean by that is you're always making choices when you design them and when you read them based on what the data is, but based on 100 other things. So I can make a visualization that is totally ethical and sort of accurate, and you might be representing the same data and you might make totally different choices and our graphics are going to look different. So we're always making those rhetorical choices. And those rhetorical choices come in with how you design it, what labels you choose to use, what those words even are, but also how you gather data, how you parse it out and organize it, how it's represented on the graph or the data visualization in a bigger way. Even the colors you choose, which axes you choose to use, the scale. So do you decide you have this big set of data over the course of 20 years? Do you decide only to show the last year of that data because by focusing in on that last year, it shows a huge hike? Or do you take and you show the entire 10 years even though it only shows it going up in that last year? So you can represent data differently depending on the scale. And then visual data visualizations always make an argument of some kind. Yes, you're representing data that is true, but by doing that and making different choices, you're making different arguments with that data. So there's a lot of considerations of ethics and audience, how people come to this visualization, how they're able to read it, what decisions you have to make as a designer to get them to understand the data quickly and correctly, that make this highly rhetorical. Okay, so hopefully working with this a little bit will make you a more savvy designer of data visualizations, but also a user, somebody who can read a data visualization and really analyze it and sort of interrogate it. And again, I'm guessing if you ever have to write a report or do a presentation as a professional, that data visualizations are going to be part of what you have to do. Okay, so the construction of these might be super important for you. I'm going to go through some basic types of data visualizations, how we use them and why we would use certain ones over others. The first few are super basic, so if you want to skip ahead to maybe infographics or something, feel free to do so, but I'm going to run through these really quickly. First of all, bar charts, they're one of the simplest forms. You guys know what those are and what they're used for. It shows relationship among things and also change over time or change over groups. Here we have in the middle what they call a stacked bar chart. And that's when you have the regular bar with different colors inside showing sort of parts of a whole. So the one column would be the whole, and then the different colors inside of each column would be parts inside of it. These can be useful, but most of the time they actually are not useful because you'll see in this example that I've pulled, you have the same 3 colors in each bar, but they're so weirdly dispersed that it's hard to look at this and in a moment really see the trends and what that means. It's harder to read because the data is almost too complex. So there are lots of ways that you could parse this out, but it's not really a well-designed graphic because it's not readily apparent as soon as you look at it. And that's one of the joys of bar charts, is that they are so simple and easy to read. So if you make them too complex, you sort of lose the whole point of this really simple data visualization. And we have line graphs or area graphs, depending on how you represent them. These usually show change over time or increases and decreases. If you watch the beautiful data video, which you were supposed to, this one might look familiar. So line graphs can look like this, which is very traditional. And we have 4 different things represented, and it moves up and down depending on time and volume. And by showing 4 different things, we can see a relationship between these and how they're moving. Okay, that's basically what you would use a line graph for. But there are also much more complex line graphs, like this one that you see up here, that's showing multiple kinds of data in one chart, and also area. So this one has lines and area. So line graphs are simple, but they're sort of deceptively simple. Okay, box and whisker plots. These are related to bar graphs, but box and whisker plots are generally used more with heavily statistical data. So if someone has really run their numerical data through some statistics, you can get something that looks like these. And it's sort of like a bar chart, but it has these little whiskers or tails on it. And this visual right here shows you what each part means. I assume most of you have taken some kind of basic statistics class. But you can also think of this, so the median is the middle, and then we have the quartiles. So the box is really where most of the data lies, inside of that box. And then these would be like the outliers, the extremes above and below. That's where these lines come in. Those are outliers. And then you can have single outliers, which fall even outside of the purview of that box. You don't see these used very often because they are more difficult to read at first glance for most users, unless you're used to working with statistics a lot. You also might see them lined up together instead of just one. You'll see a group of them, which can show relationship, but these are a little bit harder to read. Okay, we have basic scatter plots, which reveals a relationship between 2 variables, sometimes change over time. You can do more than 2 variables if you use color or some kind of design principle to differentiate between your variables. It also shows trends, and it's really easy to see the outliers when you use a scatter plot, because you're plotting everything basically on an X and Y axis, and then sort of visualizing where the line goes through to see the trend. So you'll see that here on this example. Positive correlations, negative correlations, etc. And here that they've scattered everything. So they've plotted each data and drawn a line through it. Now that line is not exactly where all the data lie, but it just shows the general trend of where the information is going. Sometimes you'll also see this in like 4 quadrants. This is a silly one that I found. This is a scatter plot as well, even though it's not only in this sort of 1 quadrant, it's broken up into 4. Pie charts are other very simple, really easy to read graph that we see all the time. It shows parts of a whole and compares percentages within that whole. Pie charts always have to be based on 100%. You guys know that intuitively when you read them. But these are the fastest to read because they're graphically super simple. And to be useful, they always have to come with a legend, because honestly, without this legend over here, this actual graph could mean anything. Okay, so infographics. Infographics can be defined in a lot of different ways. It really, at its basic core, just means information that is made visual, information that's turned into a graphic. But when we think of infographics, we usually think of something like this. And I have some links. I'm going to pull them up. Okay, so I have some links here. You can click on these. These are just basic examples of what we traditionally think of as infographics, which tend to be really long, scrolling, well-designed representations of like a narrative about one particular topic, and then you'll have a lot of text and a lot of different kinds of graphic or visuals, data visualizations put into sort of one theme in one unit. So this is a different type of data visualizations, but really it's a bunch of data visualizations like sort of molded into one object. So it's really not a data visualization on its own, it's a bunch of them put together. But this is something that's available to you if you want to work with a longer infographic as part of your final project for Project 2. So, real quick, multidimensional data visualizations use 2 or more dimensions and compares like 2 or more sets of data. Bar, line, scatter plot, pie charts, these are all examples of multidimensional data visualizations, okay? Anytime you're comparing at least 2 or more things. And then we have things like hierarchical data visualizations, which show hierarchies, or they might show how certain things are put together to be part of a group, or how a big group of things breaks down into its individual components. Over here we have a tree diagram, so we start with something big. Think of like kingdom, phylum, class, order, family, genus, species. The kingdom would be the biggest one, and then it breaks down into phylum, etc., etc. Ring charts, you've probably seen these. These also can often be bits of hierarchical data visualizations because, again, it's based on 100% whole and it's broken out down into these sections. We also have things called network data visualizations, which is really a representation of some sort of relationship, some sort of network. They're also called node link diagrams because each of these little circles is a node, and each line is how that node links to another one. And you see these a lot with if you're talking about processes and networks, but they can be used for people. You can think about social networks and how people are connected through Twitter, for instance, and graph it out like this. So there's some examples of that. I'm sure you guys have seen them around. But again, this list is not exhaustive. And people often take the simple ones and sort of mesh them together to create new kinds of data visualizations. And because we are falling into this just so highly visual environment, we're always coming up with newer forms of data visualizations. So there's a link here to Data Visualization Catalog, which sort of outlines a lot of different kinds, although again, not every kind, but a lot of different kinds, and tells you when you would use them, why you would use them, what they show, and sort of like what kinds of data you might use with each different kind of graph. So I encourage you to check out this website. I've linked it as a resource on Blackboard. It just helps you get familiar with this. It'll help you come up with ideas for your final project as well. This I've inserted for a look at what not to do. So this is just a fun little list that I found of the worst charts of all time. A bunch of different kinds of data visualizations that are just done poorly. They're either designed poorly, or they're based on inaccurate information, or they're not easy to read. They're just too complex and people can't read them. So sometimes it actually helps you design better when you can look at stuff that was designed badly. Because it's a lot easier to look at something that was done badly and point out why it's bad than it is to look at something that was designed well and point out why it's good. Because good design sort of falls into the background. It almost becomes invisible, and you just get the experience of like being in the data or being in the visual. But bad ones, there's obviously there's a wrench in the system, and that's easy to find. So I encourage you guys to click on this link or copy and paste this link and start looking through some of these. There's short little captions under each one that tells you like why it's bad. But this will help you come up with a list of like things not to do in your projects. Some of them are really easy to do that you might not even think about, and some of them are obvious. So take a look through this, just scroll through it real quickly and see if you can find like some terrible ones. This week is sort of a light-ish week on homework and stuff because you guys are finishing up your big projects. We don't have a reading quiz this week, but please go on and watch the beautiful data video that I linked on Blackboard. It's also going to help you sort of see the possibilities that are out there for you and think about your final project. It's a relatively quick like TED Talk video, and it's really interesting. Normally you could watch a lot of these videos just like with your headphones, but this one you're going to have to actually like sit down and watch because it's based on data visualizations. But it's a really good video. So please do that. Look at the rest of the notes under week 5 and let me know if you guys have any questions.